Hey guys, Mr. Nakmi here. Looking to finish up our notes for 6.2 today. Confidence intervals for population mean, right? When our sample size is less than 30, right? We're using the t-distribution if you remember from last time. And the only thing that really changes is this guy right here. This Z critical has now become a T critical, right? And we use a new chart to find that value. And that new chart is on the T distribution right here, okay? So make sure you're looking at the level of confidence, and then you also find out this guy, the degrees freedom, if you're using the T distribution, okay? And we're gonna talk about today, how do we distinguish when do we use the T distribution and when do we use the normal distribution, okay? So this is the example we did last time, all right? And hopefully you guys did the U-try and submitted that problem already. Today let's start off by doing another example here. You randomly select 12 Honda Civics that were sold at Norm Reeves Honda dealership and determine the number of days each car sat on the dealership's lot before it was sold. The sample mean is 9.75 days. That's the sample mean. And the sample standard deviation is 2.39 days. Sample standard deviation. Construct a 95% confidence interval. Oh, I read that wrong. 99% confidence interval for the population mean number of days the car model sits on the dealership lot. Assume the days on the lot are normally distributed, right? Assume that they're normally distributed. Okay, a lot of information here. Let's go ahead and start writing this stuff down, right? We randomly select 20 Honda Civics. That's our sample size. N is equal to 20, right? Right off the bat, that should tell you that this is something we know it's not a guaranteed that we're going to use a normal distribution, okay? Next thing they tell us is the sample mean, which is 9.75, and they tell us the sample standard deviation is going to be 2.39, right? Confidence level interval of 99% is going to be C is 0.99, and that should be enough for us to calculate our confidence interval, which is this equation right here, right? We have our X bar, our mean of our sample, and we just need to find out our margin of error, okay? So on our margin of error, we're going to need a T critical. So T critical comes from that chart, the T distribution, right? We have here a sample size of 20, so that tells us that the degrees of freedom then is, if you remember, is just the sample size minus 1, so that's going to be 19, and our confidence level is 99%. So we just go ahead and look that up on the table. Let's go over here, our T distribution. 99% is this confidence level right here, and our degrees freedom was 19, right? So that tells me that my T critical is going to be 2.861. 2.861. Let's go ahead and write that down. 2.861. Okay? Now that we have that, I have my T critical, my sample standard deviation, and my sample size. I have enough there to calculate my margin of error. So I'm going to go ahead and do that. E is going to be equal to T of C, which is 2.861, times my standard deviation, which is 2.39 of the sample. Divide that by the square root of 20, right? Plug that into a calculator. Let's do that real quick. We're going to have that here if this turns on. Let's go. Oh, there we go. Okay. 2.861. Right, and we're going to be multiplying that with 2.39 divided by the square root 20. Boom. Right, close that off, and that gives us a margin of error of 1.529 or 1.53. 1.53. That's my margin of error. Okay, we just take that now and we just add it to our sample mean. So I have here my sample mean in this case is 9.75 minus my margin of error of 1.53. That's going to be less than the population mean, which is what we're trying to estimate around, right? And that's going to be less than 9.75 again, but this time plus 1.53. Right, I got the right number, right? 1.53? Yeah. Okay, so we just add those and subtract those. So let's see here. 9.75 minus 1.53 That's going to give me 8.22, less than the mean, and that's going to be less than the same entry, but instead of a minus, it's a plus. So those two added together is 11.28. And that's it. That's my confidence interval. And yep. Now, I want you guys to try this same thing, except instead of a 99% confidence interval, I want you to try this for a 90% confidence interval, okay? And do it again for the 95% confidence interval. I want you to notice when you get your answer, when you get your mu is between these two numbers, and you get it for down here as well, I want you to compare those two. I want you to see what happens to those intervals. What happens to the widths of those intervals when you're changing the confidence interval from the confidence level from 99% to 90% and 95%. What happens as your confidence level changes? Okay, so go ahead and try that. See what you get. I'm pretty sure on your test you're gonna have a question that's gonna have you compare those numbers and explain in a few short sentences, or in one short sentence. After that, here's another example. If you need some practice, you will have a question like this on your quiz on Monday. Okay. All right. Moving on. Now this is the part that's a little weird. How do you know when to use your Z critical or your T critical? Right. That's the part that's gonna mess most students up on this section. It's fairly simple and an easy thing to mix up. But at the same time, once you get the hang of it, you know which one you should go with. And we're going to start off right here at the very beginning. Is your sample size greater than 30? If it's greater than 30, then you go ahead and use the normal distribution. That's it. You're done. Your sample size is 65, and then you're going to use Z critical. You're going to use the normal distribution table. Okay? If it's not greater than or equal to 30, for example, a number that's less than 30, like, I don't know, 15, right? If it's 15, then we're going to go this route. And the next question you need to ask yourself is, in this example, is the population normally, or, and this is the key word here, approximately normally distributed, right? It doesn't have to be perfect, it just has to be approximately normal, right? And if it is not, if that's a no, then you just can't do the problem, right? We can't use the normal distribution or the T distribution. If it's a no, we just say, this problem's done, can't work it, okay? If it is normally distributed though, this is where it splits into two, okay? And it comes to this symbol right here. If you recognize that symbol, that's the lowercase sigma, that's your population standard deviation. If your population standard deviation is known, then you're still gonna go with the normal distribution, right? You're still gonna go with the normal distribution, even if your sample size is less than 30. If you know the population standard deviation, that's enough for you to use this Z score instead. If you don't know the population standard deviation and you only know S, which is the sample standard deviation, then we're gonna go with our T critical, okay? That's what helps us figure this out, okay? Whether we know the population standard deviation or we don't know the population standard deviation, after you look at the sample size, okay? That's the main thing you gotta look at first, is the sample size. All right, let's do a real quick example here. We're not gonna solve for the interval. We're just gonna figure out, are we gonna use the normal distribution, the T distribution, or neither for this one, okay? So we're gonna go ahead and read this through. You randomly select 25 newly constructed houses. The sample mean construction cost is 181,000 and the population standard deviation is 28,000. Right. Assuming construction costs are normally distributed, should you use the normal distribution, T distribution, or neither to construct a 95% confidence interval for the population mean construction costs? So right here, we see that n is equal to 25, right? So it's not greater than or equal to 30, so we got to double check, first of all, is this normally distributed? And it says it right there. Yes, this is normally distributed. So we can use either, well, we got to figure out, is it going to be the normal distribution or the T distribution, right? And this is where the next part comes in. What kind of standard deviation are we given? Is it a sample standard deviation or is it a population standard deviation? Since it's a population standard deviation, that tells us that we're going to be using the normal distribution. Okay? Whoops. The normal distribution. That's it. So you're going to use the Z critical instead. right? So when you find your margin of error equation, it's going to be z critical times the standard deviation over the square root of n. That's the one we need to figure out for this one, okay? And that's it. That's from 6.1 instead of 6.2. It's not like this section, right? But it's the exact same thing. Once you find out what E is, it's just going to be your sample mean minus E less than your mu less than your sample mean plus E. That's what your answer is going to be, okay? So I'm going to leave you off here with the you try. You don't have to do this problem unless you want the practice, but the question is asking, is this a normal distribution problem? Is this a t distribution, or is it neither? And if it's neither, that means you can't actually, right now, calculate the confidence interval. It's one of those situations where you're like, I want to do this problem, but there's not enough information for me to do it. All right? So go ahead and try to figure that one out. This week, there's no example problems for you to turn in on Canvas. Instead, I want you to just jump right into the homework, okay? The homework will be posted on Canvas. Have you guys work that out and get that done for me, okay? Other than that, have a good weekend. I'll see you guys in the next video. All right, bye.